morning everyone. Today I am going to present our topic Analyze and Design of Clocked Sequential Circuits. This presentation is part of our course Analog and Digital Electronics. Myself Praisy along with my team members Prashant, Rajeshwari and Ramanidharan. We'll explain this topic. Let's understand what sequential circuits are. Sequential circuits are digital circuits that stores information, meaning they have memory. Unlike combinational circuits, their output depends not only on present input but also on previous output, which are called states. These circuits are widely used in applications like counters, registers, and control systems. The memory in these circuits is mainly achieved using flip-flops. Clocked sequential circuits. Now, coming to clock sequential circuits, these circuits change their state only at specific time intervals, not continuously. This controlled by the clock signal, also called a pulse. Because of this, the circuit works in the synchronized manner, avoiding unwanted changes and giving stable and predictable outputs. They are commonly used in processors and digital systems. Basic component are a clock sequential circuit consists of four main components. First, flip-flops, second, combinational logic, third, clock signal, finally feedback part. First, flip-flops, which stores binary values like zeros and 1. Second, combinational logic, which decides the next stage. Third, the clock signal, which controls when the change happens. And finally, the feedback path, which connects output back to input. All these components together form what we call a state machine. Types of flip-flops. Now, let's look at the types of flip-flops. We have SR flip-flop, which perform basic set and reset operations. Then JK flip-flop, which improves SR by removing invalid states. Next is the D flip-flop, which is most commonly used because it stores input directly. And finally, the T flip-flop, which toggles its output. Each flip-flop has its own characteristics and excitation tables, which are important for analysis and design. The clock signal is very important part. It is periodic square waveform that decides when the circuit changes state. There are two types: positive edge triggering, negative edge triggering. Important parameters including frequency and time period. Using a clock helps avoid timing errors and ensures proper operation. Analysis. Now let's how to analyze the clock sequential circuit. First, we identify the type of flip-flop used. Next, we write the input equations of the flip-flop. Then we determine the next stage equation. After that, we construct the state table and draw the state diagram. This process helps us understand how the circuit behaves step by step. Let's move on to the application. Clock sequential circuits have many real-world applications. They are used in digital clocks, counters and registers, traffic light controllers, sequence detectors. These applications show how important these circuits in modern electronics. To conclude, clock sequential circuits are very important in digital electronics because they provide controlled and synchronous operations. Fundamental in digital electronics, proper design ensures reliability and efficiency, and its analysis ensures the system works accurately and reliably. Thank you for listening and stay away for more informations.